First of all, thank you so much for having me, inviting me to this conference. I have learned so much. I wish there was more people from my team here. It's been interesting and inspiring. My name is Todd Johnston. I'm the Director of Education Content at Sphero. Our team is the team that puts together lessons and resources for schools and students to use with our robots and our building kits. The other part of our team goes out into schools and delivers professional development and helps schools integrate our products into their curriculum and to make sure we're meeting their learning objectives. One thing that's neat about my team, I think, is that every single person has a background in the classroom. I myself was a teacher for 10 years, and to this day, it grounds every decision I make. So for those of you who don't know about Sphero, we create robots and other modular building kits that help students learn and apply computer science and engineering skills with hands-on experiences with physical products. That bit about being hands-on, physical, is the most important part of our company. When I move on, I'll give a very brief history of Sphero. We were founded in 2010 by creating a round robotic ball called Sphero. At this point, this was 100% a toy. You could connect it to your phone, you could drive it around, you could have fun with it. We continued that evolution in the 2010s, and we made a toy called BB-8, and it came out in conjunction with the Star Wars movies. This is by far, maybe not our most popular, but definitely our best-selling robot of all time. At this point in time, we were doing nothing for the classroom, but we did notice that classroom teachers were picking up these robots. They were bringing them into their classroom to spark that curiosity and build that engagement with robotics. And Sphero noticed that. And so starting in 2017, we started a pivot towards education, and we launched the Sphero EDU app, and that had a block-based canvas that was built with Scratch blocks, and hence Blockly, and hence why I'm here today. Quick caveat, I am on the education side of things, so if you have technical questions about our implementation, you can email those to me, and I will be happy to get answers to you at a later point in time. But anyways, as we picked up steam in education, you can see by 2019 we released a round robotic ball called Bolt, the latest evolution of Sphero and BB-8, and this one was purely based for education. It came in class sets of 15, it came with curriculum, and we stopped kind of marketing towards consumers. This continued on. We continued growing our offerings. In 2020, we acquired Little Bits, and that kind of broadened our horizons towards getting into engineering and robotics. Best exemplified by last year, we released a modular building kit with mechanical and electrical pieces that you can build these mechanical structures, and then you can power them with these electrical bits. This is not related. There's no programming in this. You just are building electric chains. So last winter, I connected with Josh, and he told me about this conference. And they said they were interested in figuring out, how education people, instructional people like me, work with engineers at Sphero. So I was thinking about this, and I kind of wrote down some of these, what I consider guiding principles, and they seem very common sense, but I just want to go through them really quickly. First of all, we take what we call a content-first approach to product development. Primarily, that means hardware development, but it also relates to software development. So the education team kind of sits at the center of Sphero, and then everything we do kind of comes through our team, and we make sure our products meet the needs of teachers and students in classrooms. Second, we are a 100% remote organization. I am based in Portland, Oregon. I'm the only Sphero employee in Oregon, but we have a pretty good remote work culture, and it's 100% based on being in close communication every single day. And then last but not least, all teams at Sphero, not just the education team, is expected to get into classrooms and see students using our products because that is the best source of feedback. So now that you know a little bit about this, what do we care about? And here I think this is best told through a story. So we have a little competition called the Sphero Global Challenge. And this is remote as well. Students work in teams to solve challenges. They record these challenges, and we watch the videos. Then we have a chance to interview them in person. So this challenge is you take a robot, which is Rover. This one has tank treads and moves pretty accurately. You build a trailer for it. You drive Rover through these obstacles. You park the trailer in the garage. You then program Rover to autonomously drive back to start. So it's a pretty simple programming challenge, but we had a student this last year that I had the opportunity to hear talk, and this is his work. And instead of just programming Rover to go back at 90-degree angles to start, you could see that this student, he's a 5th grader, Jace, built a whole bunch of triangles. Then he used the Pythagorean theorem to calculate the distances of those hypotenuses. Then he plugged those values into the roll blocks to find the most efficient way. So like here is a student who has done a tremendous amount of problem solving and a tremendous amount of math that made us very, very happy. And I had the opportunity to listen in on this interview, and I think he actually said our priority better than any of us could. So Jace had some experience doing summer programming camps and things like that, but here's him talking about working with hardware.
Robots, there are all these variables, like there's wind, there are so many things that could happen. Like there could be a bump in the ground and that could set off your whole code. There's just so many more things you have to think about with the hardware.
So what does this mean for us? And to me, it means that we kind of have to get out of the way a little bit. And we really care about teaching programming concepts, but our core mission is to open the doors for more students to engage with programming and engineering in more situations. And so, like, behind that priority, that's what the software team and the education team are really focused on. I'm going to give 3 examples of things that we've done. And the first one here, this is just a screenshot of our web-based programming environment. And these are things the software team and the education team have collaborated on. In the upper right-hand corner, you can see a sign-in button. Up until 2 years ago, we used to require students to sign in before they could do any programming. So you talk about Elizabeth, I'm not sure where she was talking about the cognitive load, the extra parts of tasks before you can engage with the assignment. This is it. We stripped that out of there now so kids can go to this URL and they can start programming without signing in. We've eased the connection process. Round robots don't really have a front, an obvious front of the robot. So we've made it easier to aim those robots. Looking at the data, we noticed that students primarily use the same 20 blocks in our programming environment. So we kind of hid those extra 80 blocks and are focusing on those 20 that students are most likely going to want to find really quickly. On the instructional side of things, the education team is really focused on the lessons that we're providing, making sure that they're first of all reasonable to accomplish in a 45-minute instructional block. The language in them is readable and understandable by all. And we have taken a lot of the background information and put together lesson guides to help teachers facilitate these in more of a group setting, as opposed to asking students to work through them independently, because we just feel like that was not working. The second one comes directly from being in classrooms watching students. And it's funny, I'm looking at this block and then I'm looking at all the new stuff that's happening in Blockly and accessibility and things. I'm scratching my head wondering what we do, but that's a problem that you can email me about and someone else could answer. But this is our roll block. We have a speed input or an argument in that roll block. kids use that slider to set the speed. They can never get it to say exactly 100. And kids didn't realize that the number itself was a button that would open a touchpad. So we made that number look like a button. And now all of a sudden, hey, kids are using that button. And my third example is, there was a talk yesterday about levels of abstraction. Our robots have sensors in them. The number one most important thing for us is that teachers use, is that students can use that sensor. So we have an ambient light sensor. Previously, if you wanted to build that ambient light sensor into your program, you needed to use an if-then-else statement and build a condition. And then just this last summer, for our newest Robot Bolt Plus, we made a new event. And you could drag that out onto the screen. And once you tap on it, it actually shows you the current value of the light sensor on your robot. And then you could really quickly make a statement and have your robot act on it. Doesn't mean we don't want students to get here, but this is a first. We were finding that no students were getting here, period, right? So this is a method to then get to their next. So those are the three examples I gave. And then I'll just end going back to this same story and that same example. I was not in this talk with this student, but the very next day, this is a solution that another student presented. And you could see it's important for us to open doors to students in engineering and robotics because we feel like if we attract more kids, if we give more kids an entry point, they can do more things like this. So they're actually using operators to calculate the hypotenuse of those angles. And more than that, they're using this advanced math operation to do some trigonometry to calculate the headings of those blocks. And this one, I think, was a 7th grader. So I think just like giving kids room to run, letting them in, and then giving them room to run. And with that, I think I'm at the end of my talk.